Good morning, good afternoon, good evening. How are you guys? And welcome back to another video of TESI, a YouTube channel for theoretical and experimental scientific investigations. So today there's not gonna be any theoretical or experiment done, but this video has been done just to create like a brief example on how to read the voltage signal from Arduino to Matlab. So how to transfer the data. This video has been based on a previous video that I published recently, and so let's proceed. So what we have here basically it's just an Arduino board like this, which is capturing substantially the voltage okay, from a sensor. This is a DRV5055. If you haven't done that yet, go on one of my previous video where I demonstrated how to capture the magnetic field by using the sensor in the Arduino, and today we're gonna transfer the data directly to Matlab. So the way we're gonna do is the following thing. First of all, we need to open Matlab. Then you're gonna go right here, get add-on. The add-on explorer will be opened, and let me tell you, this is basically an academic use of Matlab because I'm a researcher at the University of Spain, Alcalá. So you search for Arduino here in the search bar. I have already installed, okay? Once you install it, you click this one, you install it. Here it will tell you install. You have two options, install it or download the package. I install it directly. I tried to download it, but it seems that the connection is creating some problems. Then you close once installed. You go right here. Okay, let's remove this one. Let's make clear all. I'm gonna eliminate the variable from the workspace. Then CLC, I'm gonna clear this one. You do Arduino setup. You press enter. It will pop up. Okay. Now it's time to configure. Depending on the connection, in this case I'm using an USB cable. I go forward. So it will upload the Arduino server. You choose your board. In our case, in my case, it's the Arduino Mega. It's right here. The port is the COM7. I choose the package that I want. I don't need all this package. In reality, I don't need it all because I'm doing the basic function of Arduino, that one of reading the voltage. I don't have any servos, nothing. Program. The search bar is in progress. Yeah, success. Click next to proceed. Test the connection to make sure that you are connected. Make sure when you do this procedure that you don't have opened the Arduino program. And when I say the Arduino program, I mean this. This has to be closed. You don't need this one. So by going back, we have verified that the connection is successful. Then next, and show example. You can have two choices to capture the voltage. Or you launch the Arduino Explorer app. You press finish. And remember, I put the analog channel of the sensor attached directly to the Arduino, and the sensor is powered by 5 volts with the ground signal on the Arduino board. And you will have, once you push enter, this board, that is that one that I have uploaded. And the Matlab has developed a guide user interface that allows you to select what kind of channel you want to use. For example, analog, digital. Alright, well, I choose the analog, and basically this is the one. My voltage as shows, right? The value is at 2.47 volt, which is the same value that has been captured in the previous video. that I will put also on the bottom of the description of this one. But it is very interesting because you have, for example, the plot settings allows you to auto scale or set up, for example, the minimum value 0, and since it is powered by 5 volt our sensor, you can put 5, you click apply, and you have the entire value. If you, for example, put some magnet close to the magnetic sensor, which is a linear Hall effect sensor, you will see that the value, okay, increase, right, and then decrease. Let's make it like 10 volt, so you will see where it goes. There you go. Now yes, this, see, between 0 and 5 volt. Alright, this is one of the options. Another interesting application for this is to export all this value by pushing export log. The export log, it does this one. You go, you upload the file directly on workspace of Matlab. You make double click, and it will give you all the data, the reading 2.47, see, and is giving you also the time of the value captured. Another interesting feature is to generate the script that allows the Arduino or Matlab also to represent the signal during the time. If you push this, you will have directly the code that add-on is generating to represent your signal. There you go. And it is very basic, and from this one then you can manipulate the code as you want in order to have a different representation of the value or the voltage value that you are about to capture. Another important things that you can have with this is the choice of the kind of interface, serial, SPI, or integrated to circuit. And now we're going to show another way to create the representation of the voltage. Before, I would like to show you also the libraries that you can insert. Obviously the Arduino software has much more library, but basically this does not mean that you can not always upload this library in Matlab. There are several forum on MathWorks where the people generate a library for Arduino and where you can download it. Now let's watch it the other way. Now remember that I show you by generate script how to read the data from Arduino. It is a similar procedure. As a matter of fact, we push exit, we go here again, and I develop this code. You see that? So you try basically to represent the script made by Matlab, and then you choose what kind of style axis you want to bring to the main plot of the voltage. So you have also some other, for example, the legend. When you copy and paste your plot on your document, you want to let the reader know that that signal is a voltage. Okay, so remember, once you have this one, don't open the Arduino program, otherwise it will tell you that it's failed. Now you run it. Figure 1 appears to be over here, and there you go. You have the voltage. You take the magnet to test if it's working, and it's working. I mix up and down. I'll try to show you the sensor in this way, but yeah, there you go. See, this is the north pole, is going to be the lower value of voltage, and this is basically the south pole. South pole according to the data sheet of the DRV 5055, all effect sensor, HES. And what else? If you have any questions, you are interested in develop something else, I have already received another request to represent the signal by using National Instruments. That is very interesting application. It's much more fast because it allows you also to develop the fast Fourier transformation in real time. For example, if you have any interesting in understanding the frequency of variation, because right now, for example, if I put the magnet on the top of the sensor, right, without moving it will give basically a fixed value. But if you have the magnet that is moving during the time, you are interested in understanding the frequency content of the signal, okay, you can always develop the Fourier transformation, and or with Matlab or with National Instruments. That doesn't matter. But with National Instruments, it's more, how can I say, is more interesting because it allows you to understand and go into depth with what concern the window of time, frequency resolutions, synchronous or synchronous sampling. You have any questions, please subscribe, thumbs up. You're more than welcome to give me also any suggestions in case you need more. Alright? Thank you so much, guys. I really much appreciate it. Bye bye.